At the end of the last video, we were just about completed with our mutable singly linked list. We had implemented the apply method, the update method, the insert method, but we have not yet written remove. So remember, we are working with a singly linked list. Our singly linked list does not have a tail, it only has a head. And in order to remove something, we simply divert a pointer around the thing we want to remove. As with insert, we have to stop on the node before the one we want to remove so that we can change the next pointer to get rid of it. Also, similar to insert, if the thing that I'm removing is the first element, I have to change the head pointer. Okay, so let's go back to the code. So, as with all of our other methods, we can require that the index is greater than or equal to 0. And I'm going to have a similar if in here. If the index is equal to 0, that means that we are going to move the head pointer. So I will wind up saying head equals head dot next. And let's look at our picture to see what that would do. So heads next is this. So we'd be taking this pointer and setting it to point to what heads next points to, which is exactly what we want to do. So that would remove the first element of the list. Now this is still going to be unhappy though, because we have to return the element that is removed. Well, in order to do that, I need to remember what was in the data for the head, and then we have to give that back. Okay, so we're going to grab the data element, change the pointer for head, and then give back that data element. If it's not the first element, well, then we need to have a loop, just like we did before, that's going to walk through and stop on the element prior to the one that we want to remove. To point around it, we will simply say rover.next equals rover.next.next. Now, that line might look a little bit confusing, so let's see what that means in the picture. If I wanted, for example, to remove the 5, my rover would point here to the 2, and I would say rover's next, which is the pointer that is currently pointing to 5, it would be set equal to rover's next next. So where this is pointing. So basically it will just take that arrow and modify it up to there, and sure enough that takes out the 5, which is what we would want to do. As with the case before, we have to return the value that we're removing. So before we do this, we need to remember that data. Now that is rover's next data, because remember, rover stopped one short of the element that we're removing, and then we give back that data value. Okay, so there's a remove method. We have all of these methods written. The obvious question is, do they work? Well, as we discussed with our stacks and queues, we really have to test this. So I would like to go down here, and I'm going to add a new package under test called linked list, and inside of here we'll put a new Scala class for test singly linked list. Okay, and we're going to need some of these imports, in particular the 2 from JUnit. So I'm going to copy those from a different file. And we need to write some tests to do this. Okay. As we did for our stacks and queues, I am going to make a var list that is of type singly linked list. I'm missing an S there. Nope, and I didn't need an L at all. Singly linked list of, I'm just going to test it with ints, and I'll start it off as null. I do an import, and we get our linked list, singly linked list. So before we do any of the tests, we need to make the list. And this will simply set lst equals a new singly linked list of int. And then we can write whatever tests we want. So, there are some basic tests that we should be doing to make sure that these things work. In the end, we want to test all of our methods, and we want to test many configurations of all of them. But I'm only going to take the time in the video to write a few of them. So, for example, actually, right now, our singly linked list has apply and update and insert and remove. We didn't give it methods to actually tell us the size or anything like that. So those are some deficiencies. We're not going to fix those in this class. We're going to come back and actually write a completely different implementation of singly linked list that will actually be much more functional. So I just want to test the methods that we have. So how about we have something that adds 1. Okay, this isn't going to return anything to us. And I want to take my list and insert at index 0 the value 93. Okay, and then I should be able to say that I can get my 93 out from indexing at 0. So this is using the apply method. So technically this test is testing two things. It's testing insert and apply. Turns out the way with the code we've written, we can't actually test just a single method. So green bar, those two work at least for adding one element. How about we add 2? So I'll add a 93 and a 94. And I'm going to insert this one at 1, which is good because remember we have special code for handling the head of the list. So this case is going to insert at the head of the list, then this case won't. Obviously for thorough testing it would be good to insert at the head of a list again after we have something else in there. And that passes the test as well. Okay, so what are other things we could do? Well, we could do an update. So how about we take that same 2 there, except after I've inserted them, I'm then going to say lst sub 0 equals 5 and lst sub 1 equals 6. So I put two things there with the values 93 and 94. I change them to 5 and 6, and I make sure that that's what we get out. Okay, so update appears to work. Insert and indexing in appear to work. The only one we haven't done is remove. I'm just going to do a simple test here. A remove test, where I'm going to go ahead and add a few things. So lst.insert at 0, I will add 5. Four, 3, 2, 1. Now note I'm adding all of these at 0, so I'm adding them all at the head of the list. So the list will actually be 1, 2, 3, 4, 5. And then let's assert equals. I'm going to pull out the 3, and so I'm going to remove at index 2. That should be the 3 from the middle of the list. And then after that, I should be able to test. I'll copy these lines, and I'm going to paste them twice. 0, 1, 2, and 3, which should have 1, 2, the 3 has been removed, so 4, 5. And we run, and green bar. Okay, so there's a few simple tests. Obviously, we're not testing everything. There are some other cases, things like removing everything from the list. I also never removed from the head. We have a special case code for that. So there are lots of other tests that you probably should write, but we've done enough here that I would feel at least reasonably confident, and I leave it as an exercise to the viewer to add more tests and make sure that this code actually does what we have said that it should be doing.